In this video, we will look at the recursive function to perform search operation in binary search trees. Let us call this function as rsearch for recursive search. The first parameter is the troot, which is the root of the binary search tree. And the second parameter is the key, that is the element we are trying to search. Since this is a recursive function, we will first check if troot is pointing to a node, using the statement if troot then. Within this condition, we will check if the key we are trying to search is equal to the element present in the node, using the if statement as if key equal to troot dot element then. If this condition is true, then we will return true. Else we will check if the key is less than the element in the node. If this condition is true, we will recursively call the rsearch function, passing the root of the left subtree, and the second argument will be the key itself. In the next statement, we will check if the key is greater than the element present in the node, using the statement if key greater than troot dot element. If this is true, then we will recursively call the rsearch function, passing the root of the right subtree using troot dot right and the key. Now these recursive calls were made if the reference of troot was pointing to a node. But once the reference reaches the null pointer, that is the node does not have a left or the right subtree, then we need to return false. That is, the element is not found. Let us take an example and I will trace this function to have a clear understanding of its working. Let us consider that we are trying to search element 6. The rsearch function is called, passing troot, that is root of the binary tree, and key, that is the element we are trying to search, that is element 6. So troot will initially point to the root of the binary tree, that is node 5. The if statement is true, that is troot is pointing to the node. So the statements within the if statement will be executed. The first statement checks if key is equal to the element in the node. That is, if 6 is equal to the element in the node is 5, which is false. So this statement will not be executed. In the next statement, we check if key is less than the element present in the node. That is, 6 is less than 5, which is also false. So in the next statement, we check if the key is greater than the element in the node. That is, 6 is greater than 5, which is true. So this statement will be executed, which makes the recursive call to the rsearch function, passing the root of the right subtree and the key. So now troot dot right is node 8. So recursively rsearch function is called. The if statement is executed, since troot will now be pointing to node 8. The if condition is checked, that is key, which is 6, is equal to the element in the node, that is element 8, which is false. So the next condition is checked, that is key is less than troot dot element, that is 6 is less than 8, which is true. So this statement will be executed, which recursively calls rsearch function, passing the reference of the root of the left subtree of node 8. So left subtree of node 8 is node 6. The recursive call is made to the left subtree of node 8. Troot will now be pointing to node 6. The if statement is true since troot is pointing to a node. The condition is checked, that is if key is equal to troot dot element, that is 6 is equal to 6, which is the element present within the node. This condition is true. So return true will be executed. Now since these statements are executed using recursive calls, so the return value that is true is returned back to the recursive call of node 8, which in turn will return back the value true to the recursive call made from node 5. And finally, after the end of the recursive call, the rsearch function will return true. That is, element 6 is found in the binary search tree. Now let us consider searching for element 7. The recursive search function is called passing the root as the reference to troot parameter, and key is the element 7 which is passed. The recursive search starts from the root of the binary search tree, and troot will be pointing to node 5. The if condition is true, so statements within the if statement will be executed. The first statement is to check if key is equal to the element in the node, that is 7 is equal to 5, which is false. So the next condition is checked, that is if key is less than the element within the node. So 7 is less than 5, which is also false. The third condition is checked, that is key is greater than the element in the node, that is 7 is greater than 5, which is true. So recursive search is called passing the root of the right subtree along with the key. So the reference of node 8, that is node 8 is the right subtree of node 5. So troot is node 5 and troot dot right is node 8. So now troot will be pointing to node 8. Rsearch is recursively called. So the if condition is true, that is troot is pointing to a node. The if condition is checked, that is key is equal to the element within the node. In this case, 7 equal to 8 is false. So the next condition is checked, that is key is less than the element in the root, that is 7 is less than 8, which is true. So recursively, the search function is called passing the root of the left subtree of node 8. So troot is node 8 and troot dot left is node 6. So now troot will point to node 6. Since we are in a recursive call, the rsearch function is called, where troot now points to node 6. The if condition is true and the statements within the if block will be executed. The condition, that is key equal to the element in the node, is checked, that is 7 equal to 6, which is false. So the next condition is checked, that is key less than the element in the node. So 7 less than 6 is also false. So the next condition, that is key greater than the element in the node, is checked, that is 7 greater than 6, which is true. So recursively, our search function will be called passing the reference of the right subtree of node 6. Now the right subtree of node 6 is null. That is, node 6 doesn't have a right child or right subtree. So our search function is again called, but now troot will be pointing to null. So the if statement is false and statements within the if block will not execute. The statements within the else block will be executed. That is, the statement return false. Since we are in recursive calls, so false value will be returned to recursive call of node 8, which will in turn return the false value to the recursive call made from node 5. And finally, the recursive calls ends and we have the result as false. That means the element 7 is not found in the binary search tree. Finally, let us compute the time complexity of this recursive search function. Recursive search functions are called recursively and makes the comparison at each level. So if we assume the height of the binary tree as h, there will be h plus 1 recursive calls. So therefore, the time complexity of this recursive search function depends upon the height of the binary search tree. And we can say that the time complexity of this recursive function will be O of h plus 1, which is equivalent to O of h. So this is how recursive search function works in a binary search tree.